Hello everyone, welcome to GW Prime Live. Your where is here. I am Nibedita Mohanta, the anchor for today's conversation, and the topic is Geospatial Powering the Future of Maps. And today with us we have Dr. Ed Parsons as guest. Welcome to the conversation, Dr. Ed Parsons.
Thank you. It's very kind. I appreciate the invitation.
As the technologies have evolved over the decades, the use of geospatial information has become prerequisite for all modern day services and applications, from digital twin, digital transformation to autonomous or self-driving and automation, from mapping the physical landscapes to digital infrastructure. Over the past 2 decades, Google has been at the forefront of transforming the role of maps play in our daily lives. In today's time and age, when advanced technologies like machine learning, generative AI, big data, cloud computing are changing the mapping experience, how is the future going to look? What role will geospatial play in powering the future of maps? A little description about our guest today. We are going to discuss more about this with our guest today, Dr. Ed Parson, who is the geospatial technologist at Google and the recipient of the inaugural Professional Geography Award. He is one of the UK's leading professional geographers and has been a key driver in the technological revolution, which has brought geography to an audience who now use maps and specially enabled applications daily. In his previous role at Ordnance Survey, Ed was the organization's first chief technology officer and played an instrumental role in moving the course of organization from mapping to geographical information. So, welcome to our discussion, Dr. Ed. My
Thank you very
first
much.
question will be,
Sorry.
as the my first question is, as the geospatial technologist at Google, tell us about the role of geospatial information when it comes to helping different communities around the world.
Wow, that's a good question. Actually, I, I think it's more central than many people recognize. I think people think in terms of Google Maps and Google Earth, and that's the most obvious application of geospatial technology. But actually, it work operates behind the scenes as a fundamental mechanism, a way of sorting information. Google's mission statement, which has been a mission statement throughout Google's history, is to organize the world's information to make it universally accessible and useful to people. And one of the ways that we organize information to make it more useful to people is about geography. And that's why I, describe myself fundamentally as a geographer. I'm interested in patterns in the world, how whatever you're interested in distributes unequally around the world for many different reasons. When it comes to finding information to solve a particular problem, to answer a question you might have, geography is one of those mechanisms that behind the scenes makes that process. A very concrete example of that would be, when you're searching for a business or an activity, something that you need to be able to do. One of the ways that you can constrain the size of the problem is to use geography. So if you're searching for a hotel, or you're searching for a restaurant that you want to go and have a meal this evening, the natural constraint of that will be geography. You want to go not too far from where you are located. But as you'll recognize, and the people watching this program will recognize, to deliver on that, you need to have a very big database of literally where everything in the world is, that is up to date and continually maintained. And you need to know where you, as an individual user, are, and to join those two components together. So behind the scenes, even when perhaps you're not using Google Maps or Google Earth, nevertheless, geography is behind the scenes, helping in that process of identifying information that's useful and valuable. And that same process, if you like, you can extend outwards beyond Google to perhaps every digital business now. Geography is a key component in the way many of those digital businesses work, because we're about fundamentally distributing activity across the surface of our planet.
Thank you so much. That was a lot of geography in the
There is
answer.
absolutely, there's a
So,
lot of
geography
geography.
is everywhere. That's the basic of information.
Yeah, as a geographer, I'm really pleased. Throughout my my career, I've always been driving and convincing people that geography is relevant and useful. And it's, in the last 20 years, which, some ways coincides with the focus of Google on this, but, Google is not the only company involved with this, and they're not the only company that's moved the process on. But geography is now something that all of us use on a day-to-day basis, largely because we have smartphones in our pockets. And I would argue it's geography that makes a smartphone smart.
Absolutely. Like you mentioned, geography, I mean, smartphones and internet services are is what dominating the world right now. So in 2007, when you joined Google, what were the major challenges that you faced while merging the GIS and the with the global mass? And now that the whole world is enjoying Google Maps, like you said, and other features, what are the challenges now?
I think the key challenges at the beginning were taking a relatively niche technology, which GIS was, and probably GIS itself is still quite niche, taking that niche technology and making it mainstream, which really meant focusing on what is the key essence of what makes a GIS system useful, and stripping away a lot of the complexity. So the reason that we are all familiar and use Google Maps, Apple Maps, or whatever our favorite mapping platform is, or we use Uber or Deliveroo or Get, whatever application is, we've stripped away a lot of the complexity that goes on behind the scenes. It still happens, you still have to do all the data manipulation, but we've hidden that behind a relatively simple user interface that's focused on particular tasks, about navigation, or about doing simple local search. We've stripped away much of that complexity, much of the variability that was there in the GIS system, to focus on something that was aimed at the consumer. Um, and we took away, I think, and this is the biggest change, we took away the requirement for an individual user or a company to collect the data themselves. Geospatial technology is fundamentally reliant on data. It's reliant on accurate, up-to-date geospatial data. And in the early part of our industry, the collection of data and the management of data, and the development of applications was something that an organization had to do all themselves. They had to not only identify the tools they needed to use, but often go and acquire the data. I think when geospatial technology became mainstream, it became mainstream by removing that data management bit. Someone else was responsible for doing that. And as a result, today the challenge is keeping that data layer, that content up to date, as the requirements of our user communities get more and more complex. We want to be able to do more. We want a map that is more accurate, more detailed than has ever been collected before. And it's keeping that process sustainable. There's a huge cost behind the scenes in gathering, more and more accurate data spatially, more and more precise, higher resolution, both spatially and temporally. It needs to be not only a very accurate reflection of the world, but it needs to be an accurate reflection of the world now, absolutely up to date. And that's a huge challenge.
Yeah, I think internet also plays a lot of role in bringing the data closer to people in very short time. And now that everything is connected with internet and everything is accessible through smartphones, what does the future hold? I mean, what new innovations are we going to see next?
I think that user focus is a really important point, and it's very insightful, I think, for you to identify that. I think success for us is better continuing to better understand what the user needs to do, and to speak in the user's language. And I think we've still got some way to go in terms of delivering on that. The concrete example for you is, if you ask your favorite mapping application, whether it's Google Maps or Apple Maps or whatever, to give you directions, we still give you directions in very technical terms. We'll say, walk 500 meters north, turn left, walk 200 meters, or walk to the second junction. If you ask another human for directions, that's not what we would do. We would talk about, local neighborhood features. We would say, walk along to the building with the green door and then cross the road by the restaurant called Smith's. And then it would be a much richer description of the world around us. And why we find that difficult at this point in time to deliver on is our data sets aren't rich enough. We don't have that qualitative worldview. We're very good at absolute location. We can tell you very precisely where you are, but we're not very good at describing it. And I think that's where the opportunity really for AI comes in that we can use AI tools, machine learning models to recognize the world around us using the language that we as humans recognize. And we can end up describing the environment in a much more semantically rich way that is much more human. And I think that's a big step that we have to take to deliver systems that work at a much more human scale. And the other element of that is working at that human scale that is actually much closer. We can build a system that will allow you to navigate from my office in London all the way to your office in India, step by step. But actually, in the office or in our home, in the area that's within our line of sight, maybe 10 meters around us, our systems don't work as well. We don't have that level of ability to create and collect data at that very high resolution inside buildings. And it might be actually we don't need high resolution data. We just need to be able to recognize where things are relative to us. So we're not location, but relative location is more important. Proximity to where features are around us. The use case I often give our engineering teams to solve is I want to be able to find my keys when I lose them in my house, and you have to describe to me how I would find them. And the answer might be, well, you've left them in the bedside cabinet in the top drawer. That's a really hard problem to solve using our current geospatial technology, but it's the sort of problem we need to be able to solve.
That's very interesting, actually. So now that we are in the digital revolution phase, so how has the traditional cartography changed, and how the cartography is perceived today, and is its importance still relevant?
Oh, absolutely. I'd say it's more relevant than ever. I think the great strength of cartography, and is often it's not recognized for this, and actually not enough people study cartography, not enough people focus on the value of cartography, is that cartography is very good at abstraction, of identifying the essence of information and just describing that. And that's actually a really difficult task to do. And it's a task that's all the more relevant as we collect more and more data. Uh, Actually, for most of the world's problems, there's huge volumes of data out there. It's of variable quality for sure, but there's lots and lots of data. What we're not very good at is identifying what's the trends, what are the patterns within the data, and how do we communicate the essence of a particular data set, something that cartographers naturally do. Cartographers, the main task of a cartographer is to remove data to make a pattern clearer, to make uh, a particular activity or a particular feature more clear within the map. And that's something that we need to be able to do all of the time. Machine learning may help us do that. Machine learning is actually very good at spotting patterns, but we still need to recognize the fact that someone needs to drive that process. Someone needs to create a narrative, a reason for the map. Every map tells a story. Every map was designed to communicate a particular thing, and we mustn't forget that. That's a really important message. So I think those key skills of cartography, those key principles are really important, even if we don't perhaps focus on them as much as we should.
So, what are your views on the open source data? I mean, what role do the national mapping agencies play in providing them to the citizens?
I think open source data has been always a really key part of the success of our industry. And you can look at the big trends in open source, and I see this happening in two areas, if you like, In the Earth observation space, you look at what's happened with the opening up of the Landsat program sort of 20 years ago, and now Copernicus, where there's access to Earth observation data for anyone for any particular purpose. That's really important. You look at what OpenStreetMap has done for traditional topographic and traditional geospatial data. That's really important, and it's important for two reasons. It allows anyone to experiment, anyone to access and have a play with data and explore it and identify if the data is useful to them, it solves their particular tasks. And in the context of AI at the moment, when this is really important, it allows transparency. It allows us to understand what's going on behind the scenes, and that's particularly important as we move forward to the creation of not only foundation models, but models that are designed for specific tasks. If you're going to establish trust in those models, a key element to that is understanding the data that trained them. In many ways, and this is a point I like to make whenever I get the opportunity, in terms of machine learning, open data is the source code. It is the thing that creates the knowledge and the intelligence. And unless you've got a clear understanding of the data that was used to train a model, you're going to struggle to really trust, to understand how that model operates. So I think now there's probably an increased focus on open data. It has increased value now, both in terms of accessibility from a technical point of view, but also in a societal perspective of developing trust, developing safe systems. That ability to actually open the hood and understand how a model has made the inference that it has done is now really focusing on, well, what was the data that was used to train it, and not only the data itself in terms of what the data looks like, traditional metadata around that, the lineage of the data. Why was it collected in the first place? Who collected it? What was the original purpose? And is it representative of the activity that it's supposedly representing? Because that ability to represent accurately an activity is key in then you trusting that to train a particular model.
There is a lot of development happening in terms of indoor mapping, like you said, locating the keys from your drawer. Uh, Also in the construction field, for making digital twins of cities and countries. So, what is Google's next move in this direction in terms of indoor mapping?
Well, I never speak to the future. That's something I can't really do from a Google point of view. We don't tell, we don't say what we're going to be doing in the future, largely because in many ways we haven't decided yet. So I can't really talk specifically about Google's future plans in terms of indoor mapping. Although in general set terms of the industry, I think it's always been a challenging area. Unlike the outside, the world that we've traditionally mapped. All indoor spaces are by their very nature private. So there's a higher barrier to data collection than there is in mapping the outside world. So you always have to go through that process of, well, actually, can I talk to whoever the owner of this particular building is, the operator of this building, to start doing data collection. Data collection itself is more complex if you're doing data collection inside buildings. Building digital twins, having building information models is great, but as we all know, most buildings don't have those. They've never been created. So there's a huge task in terms of collecting that data. And then localizing yourself within a building is again much more complicated, because the traditional sources of localization technology in terms of GNSS don't work as well inside buildings. So the basic infrastructure that you can use to build geospatial content for the urban space, for buildings, is much more complicated. It's harder to scale, and that makes the whole process more difficult. Maybe, though, part of the answer is moving away from this idea of absolute location driving us. Do I really need a precise XYZ location? of where I am? Do I need a precise X, Y, or Z location of the infrastructure of the building? Or is it enough to work on proximity? Okay, I can describe where I am inside the building, inside the Google office here in London, saying I'm on the third floor in meeting room X. I can do that without having precise information. It's a proximity, as a description of my location that doesn't rely on a precise location. And maybe we can use much more of that relative location to solve many of the problems. The big use case I think that's driving the industry at the moment is a requirement to support emergency services. So the ability
Right.
to dispatch emergency services to a particular location inside a building is a big challenge that we're all trying to work out how to solve. Part of the solution to that will be just to come up with a dispatchable location that is a human description of where you are. I am in this office in this building. I don't need a precise XYZ location to do that. And indeed, the XYZ location actually, in most cases, isn't that useful. It doesn't really describe where I am in a sense that a first responder would be able to use.
Right. So, with so many technologies and innovations available now, what are the challenges that cartographers and mapping industry face now? What kind of challenges?
I think the key challenges remain really understanding our users, actually solving real problems that actually provide value to people, which often means probably not focusing so much on the technology, but actually understanding where, you know, uh, we can make probably incremental gains in terms of, activities that people need to do. Can we make, your ability to deliver a parcel 2% cheaper than it was without our technology? Can we reduce the environmental impact of journeys that we make by, smarter navigation instructions? Are there real concrete gains that we can demonstrate using our technology? That focus, I think, is still really important and key for our industry to continue to do that, not be too fixated on the underlying technology. And the other bit, though, I guess, contrasting that, is to really understand what the impact of AI might be on what we do. And I think that's something that is really difficult at the moment because the technology is moving really, really quickly. We have a lot of focus on generative AI. We have a lot of focus on foundation models, which may or may not be that useful for us in the geospatial industry. Parts of the things that we do, absolutely. And we've been using, machine learning for, at least a decade in terms of creating geospatial content, in doing feature recognition from uh, Earth observation data or from terrestrial imagery and processing, point clouds. We've been using machine learning for a long time doing that. Uh, the actual role of generative AI in creating new content, I think that's something that we still need to understand. May have an impact on user interfaces, as I said. One of the great uses of machine learning is to describe qualitative information, to create those kind of human scale representations of the world. Images are actually very good, or machine learning tools now are very good at recognizing the content of an image. So being able to describe your destination from an image helps solve that navigation task of getting you the last 10 or 20 meters to your destination, because we can say it's the building with the green door, or it's the building opposite the tree. That's a kind of a level of content that we can extract from imagery that we couldn't do previously. But I think the real challenge is this is technology that's moving so quickly. We just need to, try to understand what the possibilities are, but not be too enamored by the technology for the sake of it. We really need to focus on, is there a user value behind using this particular technology?
Like you mentioned
Mention
about
about
generative AI, machine learning, and other advanced technologies, I would like to know your views on geospatial AI.
Well, yeah. I mean, I guess you've asked me this question because I've been very clear in my opinion. I don't think there is a geospatial AI. I think, AI is as a horizontal technology. It impacts on literally in every digital process that we can think of. So, it has an effect in terms of allowing us to accelerate what we do, to amplify what we do, to do things faster, to do things at a larger scale. But there's nothing that's specifically geo about the technology. It's like, is there a geospatial hard disk, or is there a geospatial graphics card, or is there a geospatial memory? Well, no, they're horizontal technologies that improve our ability to process content, to create new products and services, but there's nothing geo-specific about it. And I think that's the argument about AI. AI, increases the capability of everything that we want to be able to do,
Right.
geo or not.
So, thank you so much for the insightful conversation. We had a great time. I hope the audience was very ecstatic about the conversation. Thank you so much for your time and support. Thank you.
Thank you so much for the opportunity, and enjoy the rest of your day.